So we're going to do the best we can. All right, so the only thing we really need to accomplish the first day of this last chapter, which is our last methods for collecting data. We've done simulations. We've done random sampling now. So the next is kind of the big world of psychology and psychological, social sciences, natural sciences, experimentation, and observation. So the vocabulary gets much more concentrated, much more technical here. I would love to think that you already know a lot of this from your science classes, but I'm also a realist, and I know that that's probably not true. Because I think I'm the only person left in the building, other than Ms. Higgins getting ready to do it too, who still teaches you actually to write up a hypothesis test, which is equivalent to a lab report like you might do in a lab in college. So I'm the one that's going to teach you how to do that. Anyway, so we'll start with observational studies. They are what they sound like they are. When you do an observational study, you just get to observe. Duh. Don't make that harder than it is. So as a researcher, you observe people or things. Most common people that do this are psychologists. So you're observing maybe a school psychologist whose teacher has referred, their teacher that's referred a child who's having some serious trouble in classes. This teacher thinks this child has a learning disability. So they're going to do a lot of observation. Parents are going to do questionnaires. The teacher is going to do a lot of observations and a lot of questionnaires. Guidance counselor is going to come in and observe. School psychologist is going to test and do a lot more observation. But you manipulate nothing. You just observe what this child does. Over a long period of time, you collect a whole lot of data. And when you're finished, hopefully you have some data that shows that this child needs some services, and we can get those services in place so that we can kind of even out the playing ground for this child with a learning disability. Or we might decide that they don't have one after all. So the biggie is that no variables get manipulated. You don't get to do anything other than observe. That's not hard. Observational study, you observe. Shake your heads if that makes sense. Okay, don't make it any more than that, okay? The purpose is to collect information about a variable called a parameter of interest. It's in italics. Go ahead and underline it if you want to. We've seen that term before. We use that terminology in the last chapter. And the parameter of interest is also what we measure when we do surveys or polling or questionnaires. So we want to know people's opinions about something. In this case, we might want to know something about how a student behaves in an educational environment. There could be a variable, or there could be more than one variable that you're observing. Useful data collection technique to examine trends or association between variables. We typically use this if we're looking for some sort of trend or some sort of an association between behavior and educational what's the word I can't think of? Success or lack thereof. The biggie is the bottom one. Big. There's a couple of there's a bold word there. Cannot, under any circumstances, from an observational study, argue a causal relationship. You might find that the student has a learning disability, but you can't tell what caused it. You can just say, there's an association between these behaviors that we're seeing and the learning disability that we seem to be seeing in this class, and so we're going to try to address those things. But you can't ever argue that what caused that to happen. So no causal relationship, association only is the biggie there. All right, moving on to the next one. You have two types. You have the retrospective studies and the prospective studies. It's just subgroups of an observational study. Retro means in the past, okay? That's a real big thing with some of the clothing these days. Retrospective means you look at what has happened before, what has happened in the past. So you pick your subjects, you pick the people you're going to study, and you go back and look at their previous records. Okay, so that's probably not what happens when you're looking at a student trying to see if they have a learning disability. So you select some studies, some subjects, and you go back and you look at maybe their old medical records to see if there was some association between a medical condition and rate of death. That happens all the time. In a prospective study, you look forward. Pro means ahead. Pro means forward. Pro means in front of. So you look at what happens after you pick the studies, or after you pick the subjects. I can't even say the right words today. So you look at future outcomes. So you pick them, then you study what happens after you pick them. That's really all you need to know about that. So just vocabulary words. So let's do some application on that next slide. I'm actually going to write some things down. That gets a little more exciting. Not a whole lot, but a little. Okay. So this is a study that was done and actually published in the American Journal of Psychology back in 2000. A group of disabled women aged 65 and older were studied. They were tracked for several years. So they picked some women and they tracked them for several years. Is that retrospective or prospective? Yeah, we picked them and we looked forward at what they did after. So if this is a study, it's going to be a prospective study. They were tracked, which means somebody followed them, somebody observed them. So it's implied that this is an observational study and it's prospective. Those who had a vitamin B12 deficiency, so some sort of pre-existing condition maybe, were twice as likely to suffer severe depression as those who did not. And that was recorded in this journal. Okay, so what makes this an observational study is one of the things you have to be able to discuss. And it really is as simple as they're just observing the women. They're not actively manipulating any variable. So let's jot that down. So only observing subjects. That's supposed to be a semicolon. No variables were manipulated. We had no control over whether or not they took vitamin B12, whether or not they had a vitamin B12 deficiency, whether or not they took supplements. No control. It just was what it was. We only get to observe. When you're asked to determine whether you have an observational study or an experiment, that's the defining difference, that one word right there. Did you manipulate anything or did you not? If you didn't, it's just an observation. Is it retrospective or prospective? And we've already said prospective. Picked them and looked ahead. Who are the subjects? Who did we study? Disabled women aged 65 and older. Okay, use the same wording as much as possible as what was given in the original problem stem. A lot of times if you change the words, you change the meaning. We don't want to do that. Is there anything hard about this so far? It's really just learning to manipulate some vocabulary. That's all we're about here. What is the parameter of interest? So what were we trying to learn about these women? What was ultimately the goal? What do we want to know about them?
B12 deficiency leads to a higher rate.
Okay, so there's really two variables. We want to know if there's an association between B12 deficiency and suffering severe depression. Now, the way I'm looking at this, there's almost an implication that there's some impact of the vitamin B12 deficiency on depression. Like, they're almost trying to say, if we have vitamin B12 deficiency, then do we have depression? Almost like a cause-effect relationship, except we can't argue cause-effect because we don't know it. We just know there's an association. If we could sort of graph this somehow, we would treat the vitamin B12 deficiency almost like the explanatory variable and the depression as the response variable. So really, the parameter of interest, what they really want to know about is this severe depression. Okay? So parameter of interest is likelihood of severe depression. Now, if you say you're looking for an association between B12 deficiency and severe depression, I think it's going to be okay. We're not going to split hairs on that. But it's really sort of the end result that we're trying to study. And the last part. So this is some kind of different vocabulary. The nature and scope of the conclusion that can be reached. So that's two issues. Nature is what kind or how powerful your conclusion can be. There's one of two answers to that. We either can argue that there's an association between the variables, or we can argue that there's a causal relationship between the variables. And we can't argue a causal relationship here because it's an observational study. You couldn't manipulate anything. So let's talk just about the nature. Okay, under the nature part, we're going to say that there is evidence of an association between B12 deficiency and severe depression. No cause effect. Don't go there. It's not appropriate. We can't know that for sure. Association only for observational studies. And the reason for that is because there could be lurking variables. Remember the old lurking variables we talked about before? There are other things that are going on in these women's lives besides just B12 deficiency. And we don't know what they are. And so the severe depression really could have a different root other than the B12 deficiency. Although there seems to be some interplay between those. We don't know what kind of relationship it is. And then the scope part. How broadly can you generalize what you learned in the study? So, they're obviously looking for a link between these two variables. Who can we generalize the results to? Does it make sense to generalize the results to men? We didn't observe any men. We have no data on the men, just on women. So that's too broad a scope. Do we know anything about young women or middle-aged women? No. So the scope of the study, so how broadly you can generalize the results is really just 65 and older disabled women. That's all we know about. We don't even know about the healthy women. So the scope of the study is people just like the ones that were studied. So the scope, so we can generalize results only to 65 and older disabled women. So we might argue that in 65 and older disabled women, there appears to be a relationship between depression and vitamin B12 deficiency. So maybe we want to consider making sure they get supplements if they don't have proper vitamins in their diet. No, just that's kind of what we're thinking. That's kind of the big picture thing. So scope is just how broad can you generalize it? Not very broadly at all. Just people just like the ones they study.
So when we're writing scope, we need to say generalize results.
It's all about how you generalize your results. So only to groups similar to what you studied is the big picture. Okay, does that make sense? Shake your heads if it makes sense. We just need to learn to talk the talk. Hopefully it'll be a logical, reasonable thing to do after we learn the vocabulary. All right, we're halfway there. We've talked about observational studies, so now let's dig into experiments. So halfway through today's lesson. It's going to go pretty quickly. You're going to get some homework time today. Thank goodness. All right, so in randomized comparative experiments, the world is really, really different because in an experiment, so in a science lab, in a research lab, in a social sciences lab situation, the experimenter gets to manipulate things. You get to decide who gets the vitamin B12 supplement and who does not. So you get to prescribe something. So that's the big difference. Underline the word manipulates. The experimenter, who is also the researcher, actively and deliberately manipulates variables. And those variables have a name. They're called factors. So that's a really, really, really important vocabulary word. Variable is the generic word. Factors specific to experimentation. So if I pick a bunch of older women and I want to divide them into two groups and give one group vitamin B12 supplements and not give the other group vitamin B12 supplements, then I'm actively and deliberately manipulating that variable, okay? That factor called vitamin B12 supplements. And when that happens, I'm now in experimenter mode. I'm not just observing anymore. I'm controlling things. The experimenter assigns subjects to treatments randomly. That's really, really important. Because if you don't randomly assign subjects to treatment groups, then you might get a whole group of women with some sort of commonality that you don't even know about and confound your results and really not know anything at the end. So you really, if you have 50 women that you can study, you want to somehow, using random number tables, using random digits on your calculator, pulling names out of a hat, pick 25 of them to put in the vitamin B12 supplement group and 25 to not put in the vitamin B12 supplement group. If it's not randomly done, you might as well throw your experiment out the window. It was useless. You didn't learn anything, and you have to start all over. Randomization has to be in there. We'll talk more about why as we go on deeper with experiments on other days. In the end, after you manipulate some variables, give these women some supplements or not, you're going to compare a response variable. So there's a change in vocabulary. Instead of calling it a variable or parameter of interest, we call the end result that we want to measure, which is whether or not they have severe depression. That's our response variable in an experiment. And we're looking for an actual cause-effect relationship when we do this. So if we randomly assign treatments to groups, and one group gets supplements, the other one doesn't, and we find out that the ones who get B12 supplements had seriously less depression than the ones who didn't get supplements, then we actually now have a reason to argue cause-effect because we manipulated the variables. So this is the biggie right here. This kind of design, a properly designed experiment, is the only time we can argue a cause and effect relationship. We'll make a note of that. Experiments are the only design that allows causal claims. Which is why the only people that get funding for new medicines are the ones who run properly designed experiments. You want some government funding for that new treatment for cancer, you're going to have to do some really, really well designed experiments and find statistically significant differences in your treatment groups. And then you can argue that the new medicine is why the cancer went away. So you have a whole different type of argument, much different nature of a conclusion there. Okay, moving on. We're almost there. We're going to look at one more page and then talk a couple of questions, do a couple of practice problems, and be done. So we're close. All right, so things like day one, things about experiments that you need to kind of start getting in your head, and we'll put more in as we go. In an experiment, the experimenter must identify at least one explanatory variable. That's your factor. So whether or not we're going to get B12 supplements would work. To manipulate, and at least one response variable to measure. So we're measuring rate of depression or whether or not we have depression when we're done. The specific values that the experimenter uses for a factor are called the levels. That's another one of your vocabulary words. So if I give one group no B12 supplements and the other group B12 supplements, I have two levels for the factor vitamin B12. In a different experiment, I might, maybe I'm doing blood pressure medicine, and I might give one treatment group no blood pressure medicine, another treatment group one level, like 50 milligrams, and another treatment group 100 milligrams. So you might have multiple, more than two factors, depending on what you're experimenting with. So in a lot of experiments, you have more than just more than two levels of the factor. We'll look at those as we go. A treatment is a combination of specific levels from all the factors. So treatment, that's another vocabulary word. We're cramming a bunch of them in today. So, for instance, let's say we take these 65 years old and older women, and we do two things instead of just one. We divide them into treatment groups, and one group gets B12 supplements and does yoga. And group 2 has B12 supplements and doesn't do yoga. And group 3 doesn't get a supplement and does yoga. And group 4 doesn't get a supplement and doesn't do yoga. So you might have 4 different groups, and you're looking to see if some sort of, meditative, relaxing exercise also has an impact along with the vitamin B12. So you might have 2 different factors. You might have the factor of yoga. You might have the factor of a B12 supplement. And then you combine those to see if there's something that you can find, some combination that works even better. So that would be a multiple factor experiment, and you might have several treatments that you combine those different factors to make. And we'll design some of those over the next few days and kind of see how that works. Now, ideally, you already would have done this in science classes. So have you? See, that's the really frightening thing. You guys are seniors, and many of you will go on to college and take lab classes. Okay, this might be your best preparation for that. That's why I'm such a strong proponent of as many people as we can taking statistics, because this might just be, if you have any kind of lab classes in college, this might be the reason you get through it more successfully. That's our hope. That's what I'm trying to get for you. Okay, keep going. In general, the individuals on whom we experiment are called experimental units. There's another vocabulary term. That's the generic. So if you're experimenting on turtles, your turtles are your experimental units. If you're experimenting on white lab mice, those are experimental units. If they are humans, we usually call them subjects. Just seems more humane. But you can call your people experimental units if you want to. You can call your turtles subjects if you want to and get by with it. It's just not typically what we do. But there's a lot of interchangeable terms there that you can really use one or the other and get by with it in experiment world. Okay, so you're going to see those kind of floating around, and just know that they're somewhat interchangeable. All right, so an actual experiment that has already been done, let's kind of pick it apart. Let's pick this one apart, and then if you need a quick stretch break, we can take one before we do that last question. So, the leg muscles of men aged 60 to 75, so we're looking at a lot of older people today, were 50 to 80% stronger after they were assigned to, underline those words, assigned to, did they get to pick? All right, so somebody's manipulating what they do. We just changed our direction. To a 16-week high-intensity resistance training program twice a week. And this was published in the Journal of Gerontology, the journal about older people and their health, back in the year 2000. A lot of older studies, because these are old notes from my old textbook. What makes this an experiment? We manipulated a variable. We assigned a training program. So we manipulated. So the researcher assigned, and I'm going to put in parentheses, manipulated a training program. That's messy, but if it's readable, we can get by with it, right? Who are the subjects?
Men aged 16 to 75.
Alright, so men aged 60 to 75. Okay. Guess who we can generalize this to when we're done? Men aged 60 to 75. That's going to be the scope when we're all done. Okay, the factors. Now, how many things did we manipulate? One. Just one. There's one training program. Okay, so there's one factor, and it's the 16, well, let's just say it's the training program. I will be a little more generic here. Training, I can't spell. Program. And how many levels? Just one. Everybody got the 16-week high intensity. I can't say it. High intensity one. Everybody got the same treatment. So one level, and it's the 16-week high intensity. Now, most of the time I would consider that a poorly designed experiment, because there was only one level. And usually you want some sort of a control group that gets something different. Are you familiar with the term control group at all? Like people that didn't get the high resistance resistant training program, and you can compare the results. That really is your best type of experiment. However, in this case, they're actually comparing, if you kind of go back to that first sentence, they're comparing leg strength before the program to leg strength after the program. So it's still a comparative experiment. So we call this, and we'll put this in the notes later, we call this a matched pairs experiment, because we're matching up the same people in a before-after circumstance. So we're comparing what they had before to what they had after, which is still we're still learning something about the relationship between the training program and the leg muscle strength. So it still works, because you're comparing before to after. Number of treatments. How many different treatment groups did we have? One. It was just one treatment. Because one factor times one level equals one treatment. Everybody got the same treatment. And the comparative part was the before-after. Response variable, what do we measure? Leg muscles, or I guess I should say leg muscle strength. How about that? Or leg strength would work. It's good enough. Nature and scope. So what kind of conclusion can we draw at the end of the experiment? Just an association, or you can do a causal relationship. You can argue, we can argue that in a 16-week high-intensity training program leads to, which is a causal relationship, stronger leg muscles. And who can we do this for? Let's just put it in the same sentence, and then we get our scope in the same sentence, in one big sentence. For 60 to 75-year-old men. So there's our scope while we're at it. So we get our nature and scope all in one fell swoop. Does it make some sense? Shake your heads if it makes some sense. It's supposed to make sense. If it doesn't, we're wasting our time. And if it doesn't yet, maybe it will after we practice some more. Okay, take a quick stretch break because y'all have been sitting for a long time. We got one more example we're going to do that has multiple factors. Just make sure we know how to call things what they are. And then we'll be done for the day. So, take a break. And I'm going to... Alright, y'all read along with me here. Is diet or exercise effective in combating insomnia? So some great question of the universe, you know. Some believe that cutting out desserts can help alleviate the problem. Well, that sounds real sad. While others recommend exercise. 40 volunteers. So you take volunteers. Is it okay to take volunteers for an experiment? Yes. Because that's not the randomization piece. This is not a sample. This is an experiment, or it will be when we're done. So you can take volunteers for that. And they're suffering from insomnia. So, of course, if they don't have insomnia, you don't need them. You're not going to take them. And they agreed to participate in a month-long test. Half were randomly assigned to a special no desserts diet. Okay? Nobody's going to pick that on purpose, probably. So that's why you have to assign them to it to make them do it and hope that they agree. The others continued desserts as usual. Half of the people in each of these groups were randomly assigned to an exercise program while the others did not exercise. And it's the random assignment that really leads us to the ability to argue a cause-effect relationship when we're all done. That is the key piece. There's other little pieces, but the randomization is the essential part. Those who ate no desserts and engaged in exercise showed the most improvement. Okay? So either sleep or eat and be happy. You can't get both. That's what they're saying, right? What makes this an experiment?
Variables manipulated.
Yeah, they were assigned, variables were manipulated. So I heard the word assigned, and I heard the word manipulated, both great words. So diets and exercise were assigned to subjects or manipulated, if you want to throw that word in there. So variables were manipulated. We didn't just observe. Who are the subjects? So the 40, let me see if I can say this shorter. Insomnia sufferers. Is that a word? Can I say it?
Yes.
Insomniacs. Oh, that's fancy. I wouldn't have got that. So you could say insomniacs and shorten that a little bit. Okay, easy stuff, right? Just learn the vocabulary. All right, got to scroll down. The factors and levels for each. So what factors were manipulated? So these are the variables, like the overarching, like umbrella variables. How many factors do we have? What didn't we manipulate? Hello, are you there?
Dessert.
Okay, so diet, desserts, diet, and Exercise. So they're the variables. They're like the categories. Okay, so the factors are like the categories. So there are 2 factors, and they are diet and exercise. And how many levels of each? How many different diets did we assign? There's more than 1. 2. We got desserts and no desserts. That's 2 levels. So 2 levels of diet, dessert and no dessert. Dessert and no dessert. And how many levels of exercise? I heard a couple people whisper, but be confident. How many did we have? 2. 2 levels of exercise. Bless you. And those were exercise and not, right? Exercise and no exercise. So in the end, you get one group that has no diet, no exercise. You have one group that has no diet and exercise. You have another group that has diet and exercise. And a 4th group that has diet and no exercise. Did I say that right?
Yeah.
I don't know. Sure. I tend to lose track. So how many treatment groups do you have? You have 4. Because you divide them in half and you divide them in half again, that makes 4 groups. Or you can think of it this way. 2 factors times 2 levels each makes 2 times 2 is 4 treatments. Okay? So all the different combinations you can make of your factors and levels make your treatments. You can get much more sophisticated than this. We'll look at a problem later on where you have like 3 different types of detergent and 2 different temperatures in the washing machine and see which one gets the clothes the widest and that sort of thing. What response variable are we measuring? Okay, if insomnia improves. Okay, because at the end, the last sentence says, those who ate no desserts and engaged in exercise showed the most improvement. So we're really looking to see if our insomnia is improving or not. We're kind of, it could be something that we measure on a scale of 1 to 10. Insomnia is terrible, insomnia is good. Or it could be, do we still have insomnia or do we don't? It might be a yes or no. We don't really know those details. Last but not least, nature and scope. So what kind of conclusion can we draw? Cause-effect or association? You can draw a cause-effect relationship. So we can argue that exercise and no desserts is let's even say causes an improvement in insomnia. I can't spell. Do we know anything about the subjects other than they were volunteers? No. So we're going to have to be kind of general about the scope. Results can be generalized to people similar to the volunteers studied. So we'll just kind of be generic there. If you had a wide range of ages and both genders in your volunteers, then you can make a much wider, broader generalization of your results. Does it make sense? It's an exercise in learning to talk the talk, learning to use the vocabulary and apply it to new situations. That's what we have to practice. So the next slide is your day 1 homework. And you have about half an hour almost to work on that. I would use it wisely if I were you, because I'm going to pour a whole bunch of stuff into you every single day from here on out, because I have to. because we've got to get through this before Christmas. Come wisely, talk to each other, fight over things, argue about what factors and levels are good for you, and